Okay, good morning, everybody. Good evening, depending on where you are dialing in from. Thank you so much for joining us today. My name is Louis Sims, and I'm the Vice President of Marketing for Nexa 3D. And today we are here to do a live demo for you guys with our XiP desktop printer and our new xCURE desktop to show how you can go directly from CAD all the way through to fully printed and post-processed part in 30 minutes or less, which is pretty exceptional in my book. Um, Before we get started, just wanted to cover a few Q&A topics. The first is if you run into any technical difficulties, so you lose audio, the video's lagging, anything like that, the best solution oftentimes is just to exit Zoom and then rejoin the meeting. That solves 99% of all the problems. If you continue to experience any issues at all, just utilize the chat tool, which you can locate at the bottom center portion of your screen through the Zoom toolbar, and send me a chat, and we will troubleshoot with you as quickly as possible. Um, the next is you'll also see a box for Q&A. This is where we'll pull questions directly for Mckenzie to answer after the demonstration. So we'll go through the full presentation, and then while the parts are finishing up curing, we'll jump into Q&A and get all of your burning questions answered. And to anyone who was already curious, maybe had a colleague who couldn't make it, this will be recorded, and we will send out a link to the recording either later today, as long as the recording is available, or first thing tomorrow at the latest. And with that, I will go ahead and jump into our agenda. So again, this whole presentation is really not to go over, features and possibilities and all of that. We are going to demonstrate to you live exactly how you go from CAD to fully printed and post-processed part in just 30 minutes with the XiP desktop printer. So with that, I'd like to introduce today's speaker, Mckenzie. Hi, Mckenzie.
Hi, Louis. Thank you.
So Mackenzie's going to do the demo, and she is being assisted by Eduardo there in the back. So hello, Eduardo. Good to see you. And what we're going to do is we're going to go through, bring a CAD file into the NexaX software, show you how to set up that print in NexaX, start the print, do a quick overview of features and materials and things like that that are available through the XiP desktop printer. We'll then, as the print finishes, remove the part from the build plate, do a quick wash in our Wash plus Cure system, and then add it to our brand new xCURE desktop for curing. And after that, we'll show you the finished part and bring that demonstration to a close and jump into Q&A. Now, as I mentioned earlier, so curing is probably going to take, I think, what, around like 8 minutes, correct?
Yes.
It's material. So while that is curing, we'll go ahead and jump into the Q&A so we can make sure we answer as many questions as possible. And with that, I will go ahead and turn it over to Mckenzie to get this demo started.
Awesome. Thank you, Louis. Okay, so before we get started, I'm just going to explain a little bit of what we're doing again. So we're going to be printing some three-way connectors in X45 Natural. I'm going to have Eduardo go ahead and start that print over there, and then we'll get in a little bit more of the details of what we're doing and how we set it up. So as you see right here, the print is going ahead to start, and then I'm going to go ahead and share my screen to show you how I set up this print and some features within NexaX. Okay, so here's my screen. So this is NexaX, which is our proprietary software that we use to prepare and slice our build files. When you first open the software, this is the screen you're going to see. As you can see, I already have XiP selected, but you have the option to select from all of our printers that we have available. And then all of our materials that we have already validated are going to show up here as well. When you select your material, it's going to go ahead and auto-populate all of the print and support settings that we have validated specifically for that material on that printer. So today we are running X45 Natural on the XiP. This is one of our fastest printing prototyping materials, and we're going to be printing it at 200 micron. It's also going to suggest this build plate type that you should use. With the XiP specifically, only the solid plate is available. However, with some of our larger industrial machines, there is an option for a slotted or a solid plate. So with that, it's going to tell you which to use. Whether you have the Pro version or the basic version of the software, you are going to see this screen. With the Pro or with the basic version, you also have access to some advanced settings right here. So you do have some controls. With that, you have your type of like base layer, wait time, and exposure settings. This is good for general use of the printers, in addition to if you're planning on just printing our validated materials at our validated layer heights. However, if you are looking to print third-party materials or different layer heights, or just get a little bit more into the advanced settings, you have access to custom settings right here with the Pro version of the software. So once I'm happy with all of the settings that I have set, I'm going to go ahead and click apply right here. And it's going to bring me into this interface. So before I can do anything, I need to import my part. So as I mentioned today we are doing a three-way connector print. So that's what I'm going to go ahead and bring in. When you import a model, you have the option to import an STL, OBJ, or 3MF. I typically tend to work with STL, so I'm going to go ahead and click on that. And then as you saw on that screen below, it's going to be checking for water tightness. This means that it's going to be checking to make sure that your mesh is intact and ready to print. So there are no holes, flip triangles, or corrupted mesh. If that was the case, then it would give you the option to repair with the Pro version of the software. So once you're here, you're going to have your part, as you can see right here. With that, you have some basic transform tools that with free translate and also set number ones along with rotation and scaling. These are also hotkeys here. So let's say you have a workflow and you want to move very quickly, you can do so just by switching fastly with hotkeys. With that, you also, let's say you export your part out of your CAD software with the wrong dimensions, you can modify it here as well. So as you can see here, that's going to change it between inches and millimeters. With that, you also have some auto-generated orientation options that for minimizing the support area or minimizing the Z height. As you see here, this is one of the features that's available with the Pro version of the software, where you can hollow a model if you're printing a very solid model. With that, you can also add a lattice infill and perforation holes, which is something we recommend doing if you are printing a hollow model or a model with an internal chamber. The next tool that is useful, especially for this case, when you're printing out multiple models, is duplication array tool. So with that, I can go ahead and duplicate out my parts in both X, Y, and Z with a set distance, as you can see here. So for this print specifically, we are printing 10 parts. You can fit more on the plate. With that, you can also do an array up in Z. So you can do that in both like facing upwards like this, and then also alternate flip. I recommend doing your duplication out in a Z stack before generating supports. So this tool is something that's super helpful if you're doing large throughput or high volume prints. So, and you also have the option to auto nest. So let's say with dental, you bring in a lot of aligner models, and you want to have it auto nested onto the build plate and mapped itself out in terms of orientation so that you don't have to spend the time rotating your parts around to make sure you're getting the most efficient organization. We have an auto nest tool right here, which helps with that as well. In addition to that, we also have basic analyzing tools such as measuring. So you have 2-point measuring and then also inner and outer diameter. And then once you're there, let's say I'm happy with my print, I can go ahead and save my model. So I'm going to bring this over here. And it's going to show you the approximate print time, which is 10 minutes. Once you slice your print, it's going to be a more accurate print time. And then it's also going to show you the volume of your print and then the number of layers as well. So with this print at 200 microns, we can print this part in 10 minutes. So once I'm happy with my print, I'm going to go ahead and click save. When it saves, it's going to create a build file and a scene file for me. So I'll get into that in 1 second. It looks like our print just finished. So I'm going to have my colleague Eduardo take it out and show you the print, and then we can go ahead and remove the parts from the plate and get them in the wash. So as you can see, we have 10 of the 3-way connectors right here. And then this is in a little bit of an amberish color. It's our X45 natural. As you do continue to do the post-processing, especially the post-cure, it is going to get a little bit more amber, which is something that you will see. So off to the side, I'm gonna have Eduardo remove the parts from the build plate and then put some in the wash. So as you can see here, Eduardo's putting the parts into our XiP Wash Station. This is both the wash and cure station that we use for our XiP printer. As you can see, he has a tub of solvent with a wireframe basket inside, which allows you to wash loose parts or parts directly on the build platform. He set the timer for a set amount of time. We have pre-validated times and settings for all of our materials that we have validated. And with that, it's going to use a magnetic spinner to agitate the resin. So this is a little bit different than that of our XWash unit that's associated with our larger industrial printers, in the sense that that one is going to, you put the parts in at the top and then it's going to lower down into a basket of solvent or a tub of solvent and then raise back up afterwards. So for this one, you're going to be manually inputting the times every single time, as opposed to that one, you can have a little bit more pre-validated settings built in. Okay, thank you. So as that's running, we're going to talk a little bit about the XiP itself and the components of the XiP. So as you see here, this is the XiP that we just ran the print on. The XiP is the smallest of our resin 3D printers. You can print anywhere from 25 to 200 micron layer height. Majority of our materials are validated at 100 or 200 micron layer height, like we printed today. In addition to that, we have a variety of materials that are validated on this machine. Anything from prototyping materials like we're looking at right now to dental to industrial, and everything in between. With that, as I mentioned, this printer is also open platform. So what that means is that if you purchase the printer and the pro version of the software, you can print your own resin as well. So you are not locked into specifically what we have validated on this machine. It operates at 405 nanometer wavelength and has 4K resolution with 52 micron pixel size, which makes it very useful in order to achieve high surface finish and feature accuracy. So as the wash is finishing up, it's going to beep and let you know that it's done. So Eduardo's going to go ahead and remove those parts. As you can see, he's lifting the wire frame of the loose parts out of the XiP wash. And then he's going to go ahead and put them onto a paper towel and pat them dry. Nice. And then once he's good with that, he's going to go ahead and put the parts in our new our new xCURE desktop unit. So this is our new xCURE desktop unit. We already have extremely fast print times, specifically, as you can see with this material right here, or some of our dental materials. However, our previous, like our XiP Wash and Cure unit, the majority of the time when printing parts like this, your cure time exceeds that of your print time. And that can really take away from the speed that we are trying to achieve with our technology. So with this, it decreases your cure time by up to 80%. So he's going to go ahead and program in a set time and power. With this xCURE, with this xCURE desktop unit, you have the option of choosing between 3 different wavelengths, 365, 385, and 405, or using all at once. So that's what we're doing today. You also have the option to select the different power intensity of the light, in addition to the amount of time that it's curing for. So you can also memorize or put in up to 8 different profiles that you can program directly on the machine. So you would just need to select a specific resin on the machine itself, and then it's going to already know the time, power, and wavelength that it should be post-curing at. So that's what really sets it apart from the xCURE unit, in the sense of the speed and amount of time that's required, but also the usability. So with that, with the xCURE unit, you only have control over the time, and then everything else is already set. Whereas here you have full control over this time, the wavelength, and the power intensity. So that's what really sets it apart. One thing that's similar between the two of them is that you do have to flip the parts halfway through. Another thing that's neat about this machine is that there is an observation window. So it's a one-way mirror observation window, as Eduardo's peeking into right now, that effectively blocks UV light. So you can observe your parts as they're curing, and then just make sure that nothing has shifted during the curing or anything like that. Nice. So with that, we also have launched with this Cure Station 3 new materials. We have our new X Pro 9400 FR. So that is our new flame retardant resin. It's V0 rated at 2 mm wall thickness and V1 rated at 1.5 mm wall thickness. It also has extremely high temperature resistance at 250 degrees Celsius. In addition to that, it has exceptional material handling. It can print and does print at extremely low viscosity so that you don't need to heat the vat while printing. So this is something along with the temperature resistance of the material that sets it apart. And this was formulated in our partnership with BASF. In addition to that, we have a new white material. This is a white modeling material called Pro 9499 White. What's cool about this material is that it maintains its bright white matte finish even after post-cure, which is something that can be a challenge for white materials, especially after post-curing. So this material has extremely great surface resolution and features. So that makes it great for modeling and then also when needing to use white material. In addition to that, we launched a new dental material as well. So that's our Ceremco Print Crown Tech material. It's a biocompatible material that's used for permanent dental restorations. So it's a composite material and can be used for inlays, onlays, veneers, and then crowns as well. However, the main use is for permanent and temporary crowns. So that's also offered in a variety of shades. Yeah, so with that, I'm going to turn it over to Lewis in case he has something he would like to add.
Yeah,
And
we've already got questions coming in, so
questions.
I think we can jump into those. Before we do, thanks so much for pointing out those new materials, and it does really kind of show that you can do desktop printing. Doesn't just have to be about prototyping. You can move into some really good prototyping as well as production applications as well, even with a desktop printer. So as we jump into these questions, everyone feel free to open up the Q&A portion of your box, and we will go through as many of these as we can. The first one starts with software, which is how we started the conversation. So a great one there. It says, can you open up step files in the slicer or just STL files?
You can't open up step files. You can open up STL, OBJ, or 3MF. So you'd have to convert it to one of those prior to importing it to NexaX.
Great. And then we had one question about how does layer thickness affect print time?
That's a great question. So as you decrease your layer thickness or get finer layers, smaller layers, your print time is going to increase because it's going to be curing more layers. So the motor is going to have to be moving at least double the amount of time, which is going to increase your print time, which is one of the reasons we printed at 200 microns today. 200 micron or thicker layer thickness is going to give you faster print speeds.
Okay. And is XFlex validated for the zip?
Yes, all of our XFlex materials, XFlex 475 black and white, along with XFlex 402 are validated for the zip.
Awesome, thank you. And then just for the audience, what Eduardo is doing right now is he's doing the flip that Mckenzie mentioned earlier. So this would be 2 4-minute cure cycles. So 4 minutes flip, 4 minutes done. So the entire cure situation is done in under 10 minutes, just around 8 minutes to complete that. Okay, next question. So this is a really good one. I'll go ahead and take this one. It says, how often do you guys add new resins to the validated list and how big is that list currently? So we currently have well over 30 validated resins. I think we're up to 35 plus now. And we add resins quarterly. So we probably add anywhere from, 2 to 4 resins quarterly. Like that's been the average that we have. So for example, this quarter alone, we've released the 3 resins that Mckenzie just mentioned. We released another 3 in May, and then I think 2 more in February as well that were dental specific. So we are very well aware that resins or materials in general are what open up applications. So that's one of the reasons why we work so hard to validate resins to grow that material library quickly, but also to give you the ability to leverage that the open nature of the system to print with other resins that maybe we haven't validated yet. Because we don't want to be a barrier for you from using this printer or for serving the application that you need with a material that maybe isn't in our library. Next question. Oh, this is a good one. Does the lubricant coating on the membrane, or like, I guess the self-lubricating membrane, is there any worry about resin contamination?
That is a good question. So the lubricant coating on the membrane does not interface with the resin itself, unless you do have a leak, then it might. So that's not a concern with proper use of the machine.
Great. And then, oh, there's another good point of clarification. So you mentioned that the zip can go down to 25 microns, but in your specification, you mentioned a 50 micron minimum. So could you please clarify the difference there?
Yeah, totally. So what I mean by that is technically the zip can print down to 25 micron layer thickness. However, for the materials that we have validated layer thicknesses down to 50 microns.
Thank you. Yeah, and that's a good clarification. So for anyone, those custom settings that she showed you, both on the pro version of the software, you can change that layer thickness. So if you're looking for something with an even higher resolution, you want to go for that 25 microns, this is where you can do that within the pro version of the software. When we say open, we mean open. I know she showed it to you briefly. Maybe we'll bring it back here in a little bit. But there's probably 30 plus different parameters that you can change, all to tweak this build style to, get it to where you want it to be if you are a proficient user of 3D printing technology. Oh, this is another great one. What is the process to change material for the zip?
That's a great question. So this is something I have to do a lot. My preferred method is to have multiple vats where I store resin in. So with that, the vat is connected via electromagnets to the zip itself. So you can go ahead and disengage that. The membrane is attached to the vat, so you can pull out the whole thing containing the resin, store it for up to 2 to 3 months in a cool, dark environment while you're printing with other materials and other vats. So you can pull one out and put one in. If you only have one vat or you want to just be switching out the material within the vat itself, there is a pour spout on the vat. So what you would do is you would pour it back into the resin container as you filter it, and then just wipe it out and then make sure it's fully clean so you don't have contamination between resins, and then pour the other resin in.
And Mackenzie, do we happen to have a vat that we could
Yeah.
demonstrate with, just kind of so people could see the pour spout and all of that? So this does not have a membrane in the bottom, just want to clarify that for everyone. But you'll get to see the features of this.
So I'll go have an Eduardo show you on the printer itself. So he's going to pull out the cartridge first. So we had a cartridge system already built in, so it's going to be auto dispensing resin as our print was going on. He's going to set that to the side, and then he's going to go ahead and disengage the electromagnets on the zip. And with that, he can pull out the entire vat. So there's currently resin in this, so he's not going to tilt it for you. However, as you can see, the membrane is still attached down below. This is the vat itself, and then there's a pour spout. Maybe if you, there we go. There's a pour spout right here. So that's where you can pour the resin out and filter it back into the container.
Yeah, absolutely. And you run a quick clean cycle that's also available on the menu. And it takes probably what, like 15 seconds total. It'll cure any additional leftover resin at the bottom. And then you peel that off. It's a very satisfying experience. Just peel that extra resin layer off and then move forward from there. So that is a billet aluminum vat. And on the bottom is what we have our catch-a-latch system, which if you've ever tried to experience changing membranes with some other printers, we know this is not fun experience typically. So we have made that as simplified as possible. So it's just 4 latches that hold that membrane into place on the bottom of the vat. So As you know, it is a consumable, it lasts anywhere from 30 to 50,000 layers. So as you get towards the end of life of that membrane, you can have that off and changed in a matter of seconds. This is not some big log involved process. I think that's important to point out as well. All right, on to our next question. We have, what is the available max size for the part? And I can answer that one. So our total volume is 4.8 liters. So that would be 195 by 115 by 210 millimeters, or 7.7 by 4.5 by 8.3 inches in the Z. So a very sizable build volume, particularly for a desktop printer.
And
And
with that, as you can
yeah.
see, the parts are done curing. So these are our three-way connectors that you can see here. I don't know if you can notice, but with it being a natural color, or X45 natural, the parts do darken to more of an amber-like color after post-cure.
Yeah. No, they look great, you guys. And if I understand correctly, it's 11:32. We started well after, so we completed this entire print to wash to curing process in under 30 minutes. So just wanted to point that out. We held ourselves to the clock, so that was awesome. All right, we'll go back into questions. So what material do you recommend that is close to polypropylene or polycarbonate?
We have a polypropylene-like material. It's our XPP 405 black. So that's what I recommend if you're looking to match the material properties.
Yeah, and then for if you're looking for more of like a clarity, something closer to a polycarbonate, we have our X Model 17 Clear, which we developed specifically for its clarity. So that would be a good option for you as well if that's what you're interested in. Okay. We have one question. Are there also materials released with 94 V0 at 0.5 mils? So unfortunately, no, not at this time on the resin side. If you look at the spectrum of resins available with V0 ratings, they are typically rated at V0 at 3 millimeters or higher, or 2.5 millimeters or higher. We were able to get this down to 2 mils at V0, so I think that is currently the best in the industry for that V0 rating. And I think we already covered that question. Do you need to shake the bottle of resin before?
Are you there, Lewis? I think the question was, as Lewis tries to get himself situated, do you have to shake the bottle of resin prior to printing? Yes, you do. That's something we definitely recommend doing. Separation can occur as it sits on a shelf or during shipping. In addition to that, if you are storing resin within the vat itself, like the zip vat, like I mentioned, we do recommend stirring it. Okay. Let's see. I'm gonna go ahead and look at the questions. Trying to figure out where he left off. Do we have an exterior grade high gloss black resin? We do have some resins that are more of a glossy finish. However, we don't have any with like a set value or ones that we specify specifically for that. Our peak like resin has a pretty nice gloss in addition to our XPP 405 resin. Let's see. Is there a material level sensor? So yes, there is a material level sensor within the zip itself. If Eduardo opens, you can see on the other side from the cartridge where he is pointing, there is a sensor that monitors the amount of resin in the vat. Lewis, are you back with us?
I'm back, y'all. Good old technology got us again. Lost internet temporarily. All
Cool.
right.
Is it possible to refill the cartridge? Yes, it is. So you can refill the cartridge. You can unscrew the entire top. In addition to that, let's say you are printing with your own resin or third-party material. We do sell custom cartridges as well. So those are empty cartridges that you can fill with your own resin, so you can utilize the cartridge system within the printer. Let's see. So do we offer any materials that are on the more flexible side, such as for printing gaskets? We do. So as I mentioned before, we have 3 different XFlex materials. Our XFlex 475, depending on color, has a shore hardness of 44A and 55A. And then a little bit more resistant, we have our XFlex 402 black, which has a shore hardness of 73A. So depending on your application, one of those might be good. Is the key guide clear material compatible with the XiP printer? Yes. So all of our Keystone materials that we have validated are compatible and validated on the XiP printer. Do we have an online calculator to check the part net costs? So within the website, there is a cost calculator. So you can import your parts, set them up, and then it's going to give you an approximate print time in addition to print cost, based off of the volume of resin. Does changing the resin type often cause faster wear on the membrane? With proper use, no. I mean, it is possible to be a little bit rough on the membrane if you're not careful when you are removing material, which could lead to increased or accelerated wear. However, if you or follow proper practices and are mindful as you are changing materials, that shouldn't be the case. Yeah, so Louis, I just scrolled through. I don't know if you see any other questions that I haven't answered or you think that we should touch on.
Yeah, so we just had one roll in for soft materials like robotic suction pad. What materials do you recommend? I'm thinking that's probably like an XFlex 402.
Yeah, I would say
recommend-
probably our XFlex 402, which, as I mentioned, 73A shore hardness
Mhm.
and is validated to print on the XiP.
Yes. And then I don't, sorry for my brief departure, so I don't know which ones you went through specifically. There are a lot of questions around the membrane replacement, etc., which all gets down to utilization here. I think that's important to clarify. So people are, I guess it's different based on use, like what you're printing, the types of parts you're printing, the operator of the printer in terms of how it might affect your membrane life. But with proper use, your membrane should last anywhere from 30 to 50,000 layers, I would say is a safe bet. But could you tell us, maybe like give us some insight as to clues about when it might be time to change your membrane?
Yeah, that's a great question. Some clues of when you might need to change your membrane. There is the possibility that peel forces increase as your membrane wears due to the lubricant wearing. With that, a way to notice that is you might see an increased like print failure, sense of delamination, or difficulty fully peeling from the membrane in certain layers. In addition to that, you might see some dents or specks on the part itself or layer lines. So those are some signs that you might need to change your membrane.
Okay, great. And then did you answer the question around air filters?
No, I did not.
So how often do you recommend changing the air filter?
That is a good question. I don't know the exact answer to that. However, I would recommend with constant use at least once a quarter, but I do not know the exact answer to that. So
Yeah, so high utilization, you're looking at probably about once a quarter. Lower utilization maybe has a little bit longer life on it. I would say probably up to 6 months. But again, it's really utilization dependent. Oh, this is a really great one that I think we've got some nice follow-up to. So someone just asked, can clear materials be dyed, like for a translucent blue or red? If so, how would you recommend one accomplish this? So actually, we just published a blog on this very topic. So we actually point you to specific dyes that you can procure. I would recommend, I mean, obviously you can do this with any of our resins, but for clear, I would recommend our X Model 17 clear resin. And then you just do a quick mix, and you can either do that and then do it in the vat, or you can mix it in the vat, again, for the protection of your membrane and extending membrane life. I would recommend mixing it outside of the vat and then um, pouring it in. But that's a really fun, cool application. We've done it a lot, here before. You can look at doing custom coloring, trying to match like a company color, anything like that. We haven't seen that affect print settings or printability in any way. So I will reach out to you individually also and send you a link to that blog. But for anyone else who's interested, yes, that is something that can be done, and we have directions on how to do that safely with your equipment. Did you answer the question about resin lifespan?
I did not. I mentioned briefly, if you're storing the resin in the vat, it's good for up to 2 to 3 months. However, there are expiration dates on the resin containers themselves, so I would be paying attention to that.
Yeah, absolutely. And so our resins, depending on the manufacturer, we have obviously our own custom resins, and we partner with companies like Henkel and BASF as well. So always pay attention to the expiration date that's on the canister, but shelf life of those resins is typically 1 to 2 years, in the unopened bottle. If once you've poured it into the vat and it's been out there anywhere from 2 to 3 months, and you would want to, if you're not using that vat, put it in our resin vat container to help shield it from any sort of additional UV exposure. And then let's see here. Some questions about dental materials. That's a little specific. A lot more around the membrane life. We've covered that quite quickly. Did you answer the question regarding a high gloss black resin?
I did touch on that, yes, but
Cool.
if you'd like to speak further.
No, no, no. I think you probably covered it then. Um, and how do you know how much material is actually left in the cartridge?
That's a good question. So as I mentioned, we do have level sensors within the zip that look at the level of resin in the vat. However, for the cartridge itself, you're not going to be getting a quantitative value or necessarily a warning. How I like to do it is kind of based off of weight. So from the top, you can lift up the cartridge, and with that, you can tell whether there's still resin in there or whether it's empty. You can also go
Absolutely.
ahead and open the lid or the top of the cartridge and check that way as well.
And you can monitor resin consumption. Like if you're sitting there with a standard, let's say you have our XABS loaded and that's your primary resin for printing, you can print there, monitor the resin that you've consumed in the printing process, and that'll give you a really good close idea of how much resin is left. However, as Mckenzie mentioned, you can refill these bottles if you want to reuse them. You could pour in the front and kind of prime it by doing a pour in the front and then supplementing that with a canister in the back. So it really depends on how you're using it as to the best way of monitoring that. And then, question about our ceramic resin. This is actually a really good one. So on our ceramic resin, does it need to be heated in an oven after printing? And so the answer to that is yes and no. So if you look at our data sheet, to achieve the highest end heat deflection temperatures, you would need to do a post-bake for our X ceramic. However, we also list the deflection for UV only cure. So if that meets your needs, then a post-bake would not be required. Okay. And, I think that really, I don't see any more questions coming in at the moment. There are a few that are just highly specific. So I will probably reach out to you guys individually, make sure that we get you an in-depth explanation to your questions. One last one came in. So the zip can handle ceramic too. So yes, zip is validated with our X ceramic 3280 material that we released with BASF. So this is a ceramic composite resin. So it's really important to remember there are multiple types of ceramic options out there. So this is using a ceramic fill to increase the rigidity and heat deflection capabilities of the resin. So it's got a high ceramic fill, it prints wicked fast. And you can use this for sure some ceramic like artistic installations and things like that, or if you wanted to use it for quick turn reusable, molding and tooling, you could do that too. If you are looking to do something that involves a secondary kind of like firing in a kiln or anything like that, where you're intending to burn out the polymer and leave a pure ceramic part, this is not that type of resin. So I just want to make sure that that clarification is made. Okay, so yeah, this brings us to the end of the presentation. I hope you guys got to see just how fast the zip and our post-processing workflow really is. I think that's one thing that people tend to leave behind. They build an ultra fast printer, but then the post-processing can take as long or longer than the actual printing of the part. And so we are working very hard to close that gap. You can see here that with materials like X45, equipment like our xCURE desktop, you can go from loading a CAD file on your printer to having a fully completed part in under 30 minutes. And that really does mean so much for product development and even moving into production as well. So with that, I'll say thank you to Eduardo. Thank you, Mckenzie, so much for hosting us today. To our audience, thank you for joining us. My apologies for the technical difficulties along the way, but at least you know it's live. And we will be sending out a recording to this. So if you want to rewatch any parts of it, if you want to share with colleagues or friends so they can see it as well, you are more than welcome to share that link. It's not going to be, user specific by any means. But thank you so much. I hope you all have a wonderful rest of the week and a great weekend.
Thank you.
Thanks. Bye.